Yes, guys. So today I'm taking questions based on quadrilaterals. Quadrilateral, as I told you, triangles, quadrilaterals, and circles. These are the three important topics for the geometry point of view or in geometry. These three are the mostly asked questions, or questions based on these three are mostly asked in the competitive examinations. So please just see towards this. This topic is very important. Try to understand each and every part of this. And I've taken this in detail. The reason is that I'll take this in 3 lecture series. First I'm taking simpler questions, then middle type, then difficult one. Or mid difficult and then the difficult one. So these 3 categories of lectures of this particular quadrilaterals is very important. Note down. Now, first of all, I'll define that what are the quadrilaterals. What are their? Quadrilaterals are defined, but areas and perimeters of them. What are the areas and perimeters of different kind of quadrilaterals? What are the quadrilaterals? Sorry, quadrilateral is a polygon in which sides are 4, or 4-sided figure. 4-sided polygon is known as polygon, which is having many sides. But in this case, if it is having 4 sides, those sides may be equal, may not be equal. That's known as quadrilateral. Quadrilateral is 4, and quadrilateral is little sides. So 4-sided figure is quadrilateral. So quadrilaterals are how many types I've just discussed about, but these questions are very important. Just pay attention to them as I'll verify each and every part of this. If there is any question which is I've not expressed in the beginning, area and perimeters of the quadrilaterals, any quadrilateral is left in between, I'll clarify that and there and there. I will clarify that there or whenever the question will arise. So the point is that if there is any problem regarding any particular topic, I'll clarify there. That there, and this is the point of this topic discussed here. So let me just first clarify that what are the definitions of these perimeters and what are the perimeters and areas of different kind of quadrilaterals. First quadrilateral I'll define. Let me define. So those quadrilaterals are different types. First of all, if there is any quadrilateral given to us, and if this diagonal is given, then if upon that diagonal they have drawn perpendiculars from the other 2 vertices upon this diagonal, then what is the area of the diagonal? The area of the diagonal will be given by half of the diagonal into some of the offsets, or they are known as perpendiculars drawn from opposite vertices to this diagonal. This is the first and foremost thing. Now let me take quadrilaterals. So what are the different kind of quadrilaterals? Let me first define them, then I'll take quadrilaterals. So first, area and perimeters of quadrilaterals. This is questions based on quadrilaterals, areas and perimeters. Areas and perimeters of quadrilaterals. Areas and perimeters of quadrilaterals. This is areas and perimeters. Alright. So first and foremost thing, quadrilateral is, let me take first quadrilateral. Any quadrilateral. A quadrilateral in which one diagonal and perpendiculars from the other 2 vertices, drawn to this diagonal, then area of this diagonal, then area of this diagonal is equal to half length of the diagonal, that diagonal, okay, into sum of the perpendiculars or offsets. We say perpendiculars or offsets. They are known as offsets also. Offsets or perpendiculars. Offsets or perpendiculars to this diagonal. Perpendiculars from other vertices. To this diagonal. This I have just to this diagonal. This is how some of the perpendiculars or offsets from other vertices, other two vertices. This is other two vertices to this diagonal. Let me now draw. For example, if there is a quadrilateral like this, this is a quadrilateral like this. So this is quadrilateral ABCD. Okay, this is ABCD quadrilateral, and the AC we have drawn at its diagonal. AC diagonal, BD is also diagonal, but only one diagonal will be given, AC. Okay, then perpendiculars from the opposite vertices, the other two vertices, are drawn to this diagonal. This is a perpendicular. Let me take this is E point, this is F point, or let me take E this. This is E here and this is F point. Okay, so therefore area of this quadrilateral will be area of this triangle plus area of this triangle. Area of the triangle is half base into height. Area of this triangle is half base. Base we have taken as AC. Okay, so this is equal to half. Now area of the first time, this second, let me take first triangle is this. This is AC into BF. AC the base into BF is the perpendicular or height, plus half we are taking from, and this is again AC. AC is the base for this triangle also. Area, sorry, so area of this triangle is half AC into DF or FD we could take. This is how we have taken half AC common. In bracket will be BF plus, sorry, BE plus BE plus DF or FD. We can take DF will do, because DF is perpendicular from D to AC. BE is perpendicular, BE is perpendicular from D to AC. To other two vertices, we have drawn perpendicular from other two vertices to this diagonal. And so this area of this quadrant will be half base, half area of this triangle, half base into height of, or area of this triangle plus area of this triangle, area of one triangle and area of the second triangle. Add them and total area will be calculated. So this is the formula for this. Okay, so they are known as offsets also. These are the perpendiculars or offsets, whatever you say. Okay, so this is the first quadrilateral, general quadrilateral. Any quadrilateral we can take in this way. If we are given the perpendicular heights, okay, then we can take area. We can find area of this quadrilateral. So this is the first quadrilateral, simple quadrilateral, in which perpendiculars drawn from opposite vertices to one diagonal are given. Then we can find the area. Second, let me take rhombus or trapezium. First, let me take. Okay, let me talk about what is cyclic quadrilateral. Area of a cyclic quadrilateral. Second, let me take cyclic quadrilateral. What is cyclic quadrilateral? Okay, if ABCD is a cyclic quadrilateral, We know that what is cyclic quadrilateral? That sum of the opposite angles is 180 degrees, ABCD. Suppose this is cyclic quadrilateral. And if the sides are, suppose this is A, B, C, and D. Length of these sides, length of the four sides of this triangle, this quadrilateral are given A, B, C, D. Then, sorry, area of the cyclic quadrilateral is given as under root of S minus A into S minus B into S minus C into S minus D. Try to understand. Where S is semi-perimeter, A plus B plus C plus D divided by 2. S is semi-perimeter. Small s is semi-perimeter. Semi-perimeter. Okay, and A, B, C, D are the sides of the length of the sides of the quadrilateral. Length of the four sides of the quadrilateral A, B, C, D. In this way it we take, and this we have proved. Okay, in the beginning we proved that what are the area of a cyclic quadrilateral. So this is area of a cyclic quadrilateral in which semi-perimeter is given like this. A, B, C, D are the length of the sides of this triangle, of this quadrilateral. Then area is this under root S minus A, just like triangle, but in case of a triangle, area of a triangle, we are given S into S minus A, S minus B, S minus C under the square root. Under the square root, S into S minus A, S minus B, S minus C in case of a triangle. But in case of this area of a quadrilateral, four sides are given. Here, semi-perimeter is not taken inside the square root of this. So only S minus A, S minus B, S minus C, S minus D. This is the area under the square root. Area of a cyclic quadrilateral. So this is the second type of quadrilateral. Okay. And what is the other specialty of cyclic quadrilateral? The sum of the opposite angles is 180 degree. Angle B plus angle C is 180. Angle A plus angle C 180. Cyclic means the quadrilateral is lying on the circle. Then this specialty is there. Okay. So this is how cyclic quadrilateral is different. Now let me take another quadrilateral, which is a trapezium. Okay, a trapezium is, what is trapezium? And then area, and what is area of a trapezium? Let me just define that also. Now, third type of quadrilateral, which is trapezium. Now, third is trapezium. Trapezium. In case of a trapezium, what is a trapezium? That two opposite sides are parallel and equal. Two opposite sides are parallel and equal. Are parallel. One pair of opposite sides is parallel, not equal. Not equal. But in case if it is equal, then it will be parallel now. This is not the case. Here we have, let me take ABCD. Is a trapezium. Okay, so in this line, this side is parallel to this side. AB is parallel to DC. Okay, so in this way, a pair of opposite side is parallel, but not in a trapezium. Trapezium is having this. What is the area of a trapezium? Let me just find out that. The area of a trapezium is given. Area of a trapezium is given by half sum of the parallel sides. This is known as sum of the parallel sides, sum of the length of the parallel sides. You can say sum of the lengths of length of parallel sides into distance between them, into distance between them. This is the basic formula for a trapezium. What is this? Suppose if I draw this diagonal or join this diagonal BD, or AC we could join. Let me take AC, no problem. This is A that we join ACs. So what is the area of this triangle? So we have to draw a perpendicular from C to this perpendicular, or from this to this perpendicular, or we can take, let me take perpendicular from A to CD. This is the perpendicular. Now here let me take E point and this is F point. Okay, so height is same. Height of A or distance between these two parallel lines is the perpendicular distance. This is the height H, perpendicular distance. Okay, so distance between these two parallel lines is the perpendicular drawn from one parallel line to other. That is perpendicular distance. So height of these two triangles will be same, HH. If the base is taken the first parallel, then half base into height H. Similarly, area of this triangle will be half CD base, CD taken as base, and height is H same. Sum of these two triangles, areas of these two triangles, will be this one. So half AB into, let me take H, plus half CD we have taken as a base. The two parallel sides taken as base. Now take half common. AB plus CD into H. This is sum of the two length of the two parallel sides into distance between them. Distance means perpendicular distance. Distance means perpendicular distance. This will be the height. This is the formula. In this way we can calculate the square unit, because unit of area is a square unit. So this is square unit. Area of a trapezium is this. Okay. So this H is distance between them, distance between the parallel sides. Sum of the length of the parallel sides into distance between them. This is the area of a trapezium. Okay. Questions. This is third type of quadrilateral. Now let me take fourth type of quadrilateral, which is a parallelogram that we take. So area of a parallelogram, let me take. What is the area of a parallelogram? Fourth is parallelogram. Or we simply write in symmetric form parallelogram, two parallel lines, and write in GN parallelogram. So what is area of a parallelogram? Well, this is a parallelogram here. ABC. What is a parallelogram? We know about that the opposite sides of the parallelogram are equal and parallel. Opposite sides of a quadrilateral are parallel and equal. Okay, but parallel and equal. Opposite sides are parallel and equal. This side is parallel to opposite side and equal. These two sides are parallel to each other and equal. These two are equal. These two are equal. All four are not equal. This is a parallelogram. So opposite sides are parallel and equal. Now what is the area? Now this is the side. Okay, length A, let me take. Okay, and this length is B. This is B. This is also A. Okay, so because the opposite sides are equal and parallel. This is A and this is also A. This is B and this length is B. Okay, so the two sides are given to us. Suppose. Then what is the area of a parallelogram? Area of a parallelogram is equal to base into height. Base into height. What does it mean? If I take base into height, then base is AB in this case. Height we draw perpendicular from this. Okay, this is height H. A perpendicular is like this. Okay, a straight line. Perpendicular vertical line. So this is height here. What is area of? In this way, there are two triangles. What are these two triangles? And the area of these two triangles are equal. Let me draw this diagram here. Area of this triangle equal to area of this triangle, because the opposite sides are equal. Base are same. Height will also be equal. Height is also equal. Height means distance between two parallel lines is perpendicular distance. This is height, this is the same height. Height of perpendicular from this point. It's also the same height. Same height h. Because the area of these two triangles, which are the same. So half this plus half this, half they are twice of this. Twice of area of one triangle will give us area of the whole parallelogram. 2 and half cancel out, so only base into height. Today area of parallelogram base into height. Base is suppose A into height is h. This is area of a parallelogram. Okay, area of a parallelogram. There is another method. Who the angle between these two lengths are given. These two parallel sides, AB and AD, is angle is given. Whatever angle is given, this is 60 degree, 60 degree, 120, 120 degree. Because opposite angles are also equal in a parallelogram. Okay. So if we have to find out area in by sine formula, then area of a parallelogram is also equal to the multiplication of these two bases. Okay. That means this will give us A into B. A into B means the product of the two. Let me take the product of two lengths of two sides. Product of lengths of two sides. The product of lengths of two sides into sine of included angle between them. Included angle is between A and B. What is included angle? Suppose in this case angle A is there. So included angle becomes sine of included angle. Included angle means include between these two sides. Include the angle, sine of include angle. As in this case, this is AB into sine of angle A. Now, what is we have studied that area of a triangle. Area of a triangle is half AB into angle between them. AB, the two sides into angle into sine of include angle. For example, area of a triangle was half. If it is AB, then opposite angle of AB will be C angle. Angle C will be there. The lengths and there we take the opposite to the particular angle. The length is taken as, for example, opposite to angle A is A length, B to B. C opposite to C angle is C length. In that situation, angle between the two different lengths A and B will be angle C. This is half AB into sine C. Area of a triangle. Area of a triangle in sine form, sine of that angle included angle. C angle will be there, but A and B lengths are there. Where is BC, then angle will be sine B. Half of BC into sine B. CA into sine B, or AB into sine C. Okay, or we are taking CA sine B. If it is C, then AB into sine B. If it is AB, then sine C, and if it is BC, then sine A. So half of BC sine A, half of AB sine C, half of BC sine A. In that way, there are three types of formulae used for area of a triangle in case of sine. But in case of this parallelogram, product of the lengths of the two sides A into B into sine of angle between them. Sine of angle included angle. Sine of included angle. AB into sine A in this case. A into B, where A and B are the length of the two parallel sides. Two parallel sides, adjacent parallel sides. This parallel side and this parallel side, these two are opposite. The opposite sides are parallel, but these two are taken as different lengths. Two adjacent parallel sides, we can say, and angle included or included between them, or angle included, or included angle. So sine of included angle of A and B is sine of A, and in this case, this is the area in case of a parallelogram. So parallelogram, area of parallelogram is AB into sine of A, not half. In this case, this is the area of a parallelogram. There are two types of forms for area of a parallelogram. First, half, sorry, this A into H, base into height. We can say area of a parallelogram is base into height. Base is here, this, or we can say this is base into height. Base we have already written down, base into height. Area of a parallelogram. Or second formula is AB into sine of angle A. This is fourth type of quadrilateral. Let us talk about now fifth type of quadrilateral, which is a rhombus. Now let me take what is rhombus now. So this is fourth one. We took the first quadrilateral, then second was okay. Trapezium we took, rhombus we have rhombus we have not taken. We have taken trapezium, parallelogram, okay, cyclic quadrilateral, cyclic, any quadrilateral, cyclic quadrilateral, trapezium, and parallelogram. Now rhombus, let me take. What is the rhombus here? Fourth type, or if you parallelogram, fourth parallelogram we took, now fifth one, it is a rhombus. So first we discussed any quadrilateral. Second I have discussed trapezium. Third I discussed trapezium I have discussed about. Then parallelogram I have discussed about. Third one parallelogram. Okay, it's still trapezium, parallelogram, and cyclic quadrilateral. Second was cyclic quadrilateral. This I have discussed about cyclic quadrilateral. Then third was trapezium. We have taken then third as trapezium. Fourth one as parallelogram. Now fifth one I am taking as rhombus. Sixth one I will take then sphere, sorry, rectangle. Let me take rectangle. And seventh is square. We have seven type of quadrilaterals. Their areas and perimeter we are discussing about. But in case of a rhombus, perimeter can be calculated. In case of a parallelogram also, a perimeter can also be calculated. What is that? Twice of A plus B, where A and B are the length of the two parallel sides. So that was perimeter. Rhombus. What is rhombus? As I discussed about, rhombus is a four-sided figure in which sides are equal, but diagonals are not equal. Sides are equal, but diagonals bisect each other at right angle. This is right angle. This is right angle. Okay, right angles. They bisect each other at right angle. This is AB, CD. But sides are equal. A. What is area? This is suppose D1 by 2 half. Bisect each other. Diagonals bisect each other. This is D1 by 2. This is D2 by 2. D2 by 2. Whole length of diagonal AC is D2. And this is D1. Or BD, we are taking D1, no problem. This can be taken D1 or D2. So the length of the two diagonals is D1 and D2. What is the area in this case? The area of this whole diagonal will be, if I just calculate, then diagonal's length is D1 into D2, half D1 into D2. Area of a rhombus is half D1 into D2. Means D1 and D2 are the length of the two diagonals. Why? Because the areas of these four diagonals are equal. This length is A, this is D1 by 2, D2 by 2, D2 by 2, D1 by 2, D2 by 2. So areas of these four triangles are equal. This equal to this, equal to this, equal to. Find area of any one triangle and four times of that. Area of rhombus, area of a rhombus, area of a rhombus is equal to half d1 into d2, where this is product of the diagonals, half into product of the length of the diagonals, product of the diagonals or length of the diagonals, product of the lengths of the diagonals. This is the formula. And diagonals. How do we find out this? If I just find out area of one triangle, then half base. What if I pick base this? Base into height. This is area of the triangle. This is 4 times area of one triangle. This is half base into height. Height is, let me take one triangle. What is that one triangle? 4 into area of any one triangle. Any one triangle. In this case, area of any one triangle means this is base. Suppose after this is height. Height is d1 by 2 and the base is d2 by 2. We can take 4 into half. This is d1 by 2 into d2 by 2. Why? Because d1 by 2, because diagonals bisect each other. Bisect means they divide into 2 equal parts. Each other. They divide each other into equal parts or into 2 equal parts. This d1 by 2, d2, so d2 by 2. This is also d2 by 2. This d1 by 2, this is d1 by 2. d1 by 2. Okay, so half of d1 and half of d2. This is base into height. So this 2 to the 4, I'm sorry, this is 2 only, d2 by 2. So 2 to the 4 and this 4 cancel out. Only half d1 into d2. This is left. This is area of a rhombus, square unit. Area of a rhombus is half d1 into d2. Half into product of the length of the diagonals. Okay. Now let us check next thing. Okay. Another thing is perimeter. What is perimeter of a rhombus? 4 into side. Well, the 4 sides are equal, just like a square of this. Perimeter will be perimeter of a rhombus. Perimeter of a rhombus equal to 4 into side. 4 into side. In this case, 4 into a. Okay, unit. So length is unit. Now unit is centimeter, meter.